Hello everyone and welcome to class of network layer functions. In this class today we are going to discuss about the network layer functions. Now the TCP IP network layer defines many functions which are beyond the internet protocol. IP plays a role in networking, that means defining IP addressing and routing. For example, the routing protocols like OSPF, which is Open Shortest Path First, exist as a separate protocols which are defined in separate RFCs. So network layer features include domain name system DNS, address resolution protocol and ping. Next is using names and DNS. TCP/IP defines a way to use host names to identify the other computers. For example, web browser. Suppose we have opened a web browser and we have typed www.google.com. So our computer doesn't send an IP packet with the destination IP address www.google.com. It sends an IP packet to an IP address used by the web server for the google.com. TCP/IP needs a way to let a computer find the IP address used by the listed host name, and that method uses the DNS. So enterprises use the DNS process to resolve names into making IP addresses. Suppose we have two PCs, PC1 and server 1. PC1 needs to connect to the server 1. So in the first step, PC1 sends a DNS message, which is a DNS query to the server. Then the server sends back a DNS reply that lists the server 1 IP address. After that, PC1 now sends an IP packet to the destination address, the address which is used by the server 1. So, routers treat the DNS messages just like any other IP packet, routing them based on the destination IP address. DNS defined protocols as well as standards for the test names used throughout the world and a worldwide set of distributed servers. The domain names that people use every day when web browsing like google.com follow the DNS naming standards. Next we are having address resolution protocol. IP routing logic requires that the host and the router encapsulate IP packets inside the data link layer frames. For the Ethernet interfaces, how does a router know what MAC address to use for the destination? It is with the help of address resolution protocol. On Ethernet LANs, whenever a host or a router needs to encapsulate an IP packet in a new Ethernet frame, the host or router knows all the important facts to build the header, except for the destination MAC address. The host knows the IP address of the next device, either another host IP address or the default router IP address. A router knows the IP route used for forwarding of IP packet, which lists the next router IP address. However, the host and routers do not know those neighboring MAC addresses before this. TCP/IP defines address resolution protocols as a method by which any host or router on a LAN can dynamically learn the MAC address of another IP host or routers on the same LAN. ARP defines a protocol that includes the request, which is ARP request, and this ARP request is basically a message. ARP also defines the ARP reply message, which lists both the original IP address and matching MAC address. ARP also defines how host and routers remembers the ARP results, keeping the information in the cache or table. Each time a host or a router needs to send a packet encapsulated in a frame, it first checks its cache for the correct IP address or the matching MAC address. These hosts and routers will let ARP cache entries time out to clean up the table. So, occasional ARP request can be seen here. Next is ICMP echo and the ping command. ICMP as Internet Control Message Protocol. It does primary tool for testing basic network connectivity in the ping command. Ping is packet internet grouper. It uses ICMP to send a message which is called as ICMP echo request to another IP address. ICMP does not rely on any application, so it really just tests the basic IP connectivity, layer 1, layer 2, layer 3 of the model. Ping command uses this ICMP. ICMP defines many messages that the devices can use to help to manage and control the IP network. Thank you so much.